Okay, so let's begin. Good afternoon. Welcome back. Today we'll be talking about surds. I'm sure we've mentioned this before. Does anybody remember surds? I told you you were going to do it properly later, but I mentioned it when I was saying something about exact form. Does anyone remember?
Is it like square?
Yeah, that is Justin. Numbers in this form. Okay, numbers in this form is called surds. I mentioned that sometimes during the school, when the school was still open. So it was this, okay, Justin again, when the school was still open, all right? Okay, so we're going to be discussing surds. So let's write. Date is 22nd. So for today, we should be able to simplify monomial surds and multiply binomial surds, or maybe add and subtract like surds before we go to all the other stuff. So is Anson in the class today?
Yes, I'm in the class.
Okay. So who's not here yet? So we want to be able to add and subtract like surds. Okay. If time permits, we might be able to multiply and divide. So let's say multiply surds, be it monomial or binomial. One is trying to come in. Anika. Ready? Okay. All right, so when we talk about radical, this is the radical sign. The square root is a radical sign. So any number you write under the square root is a radical, but not all of them are surds. For example, you can write this. There's nothing bad in writing this, right? But it's not a surd because it leads to a number. But this is the radical form of a number, okay? Because you put it under the radical sign, which is the square root. Okay, but it's not a surd because it gives a number. It becomes a surd if you cannot express it directly as a number. So for example, square root of 5. There's no way you can express that directly. Am I making sense? So that's the difference. So any number you write under the radical sign, you can say it's a radical number. Let's take that off. Is everyone here now? Anika is here. So can I ask Denise to look at the list, and maybe one or two people can join her and identify who is not here, then put it in the chat box, please.
Okay.
Thank you. So let's write a radical is a number that is written with the radical sign. Okay, so a radical so AG. So these are all radicals. So some radicals are rational numbers. Can you tell me which of the numbers that I've written as example is a rational number? Anyone?
Square root 1/3.
4.
Square root of 4, not 1/3. Rational. This is not a rational
Oh,
number.
sorry.
Okay. So some radicals are rational numbers. So e.g., square root of 4. What about square root of 4/9? Is it a rational number?
Yes.
You sure?
Yes. No,
No.
I don't think so.
Why?
Because 2/3 is not irrational.
2/3 is a rational number.
Oh, really?
Yeah.
Okay, never mind.
Rational number is any number in this form.
Oh, yes. It
Okay.
can be written as a fraction.
As a fraction, thank you. So that is why later you'll be learning rational functions. They are functions in this form. So we call this rational function. So if I have h of x in this form, then h of x is a rational function. For example, h of x equals maybe x plus 1 divided by x minus 2. This is a rational function. Okay? Understood, everybody, what I mean by rational function, rational numbers? All right, good. So because this would give us a rational number, then it is rational, of course. So some radicals are rational, okay, are rational numbers, e.g. this and so on. Some are irrational numbers, okay? Other radicals are irrational numbers. That's the next thing I'm going to write. Okay, so other radicals okay, I thought it's my neighbor's door. Apologies, everyone. Someone is trying to come in to check the gas. They could have just pressed the bell. Please hold on. You need to wait. Can you guys hear me?
Yeah.
So other radicals can be irrational numbers. That's the point we're trying to make here. Okay, other radicals are irrational numbers. Okay. Now, from this list, can you fish out the ones that are irrational numbers? I'm talking to class, please.
Square root 1/3.
Square root 1/3. Can Yanko think of another one not on this list? No time to waste, please. When I ask you a question, you have 5 seconds to respond. Denise, your turn.
Square root 5/6.
Good. And it doesn't have to be a fraction. Charlie, your turn. Is she in the class today? Is Shirley here? Can you give me an example quickly? Alex?
Yes.
Yes, what? Elsin?
Root 5.
You guys need to be focused when you're in lesson. Huh? I asked you a question, Alex, then you started thinking. You should be thinking along from time to time. Should be focused and, you think ahead, you think along as I'm talking in class. Now, the radicals that are irrational numbers are called surds, okay? So remember I said other radicals are irrational numbers, okay? These are called surds, okay? It's the radicals that are irrational that we call surds. So we have encountered this in different calculation. Leave your number in the exact form, leave your answer in the exact form, and so on and so forth. We have always been using this. So what we are trying to learn now is how do we, at this point, simplify, operate numbers that are in surd forms. So if you have two numbers in surd form, can you add them? Can you multiply? Can you subtract? Can you divide? If not, what can you do? Can you even find the square root of surds? Okay. There is a question I will ask you to work on later, either individually or in group. It goes this way. Square root of 2 plus root 3 minus the square root of 2 minus root 3. I'm going to ask you to find the value of this number later without using calculator, of course, showing me all the steps. All right. So for us to really understand what we are doing, we must be guided by some rules. So we call them properties. Okay. So let's just say some property, just like saying laws of log that we did, just like the laws of indices. So these properties hold for surds. Okay. So the first property we want to talk about is that the square root of A, either plus or minus the square root of B, is not the same as combining them under the same surds. So don't be tempted to say that the square root of 9 plus the square root of 4 is square root of 13. This is wrong. Can you check this in your calculator, everybody? Also, check if the square root of 9 minus the square root of 4 will give you the square root of 5. Who is ready? Are you there yet?
Yeah. It for square root of 9 plus square root of 4 is 5.
Square root of
And
9
for
plus square root of 4. The answer is 5. Yeah, is it the
Yes.
same as the square root of 5?
No.
No. So that's the point we're trying to make. So do not be, don't be this. Wait. Okay, yeah, this one. So this one
That's
gives
for
you.
square root of 13.
So this one gives you 3 plus 2, right? Which is 5 on the left. And square root of 13 is 3 point something, right? Is that not? So this is not the same. It's not going to hold. Similarly, this is 3 minus 2, which should be 1. And last time I checked, 1 is not root 5, because root 5 should be 2 point something. So they are not the same. Okay? So don't be tempted to assume that the square root of a number plus the square root of another number is just by adding them together. Okay? Either plus or minus. It doesn't work like that. Does that make sense, everyone?
Yes.
Yep.
So the second one, now while we cannot add or subtract, we can actually multiply and divide. So the square root of A times the square root of B is actually the square root of AB. That holds. And also the square root, maybe I write that's number 3. The square root of A divided by square root of B, separate square root, is the same as one single square root when they divide. We can check this also. So you can check square root of 9 times square root of 4. Maybe we'll write it here. You could see that, let's see if that is square root of 9 times 4. Square root of 9 is 3, square root of 4 is 2, this is square root of 36, this is 6, and this is 6. Okay, so that holds. And for the division, square root of 9 divided by square root of 4, let's see if it is square root of 9 over 4. Yes, because this is 3 over 2, and this is 2.25. So this is 1.5, and this is also 1.5. So this holds, okay? So that works. The last property you need to take note of is when you square a square root, whether the square root is inside the square or you square root or you find the square root of a square, you get the number under the square root. Okay, when you square a square root, you get the number under the square root. You can check that too, using any random number of your choice. Okay, so if I check with 5, for example, square it, that is actually square root of 5 times square root of 5. And because we are allowed to find the products, this becomes square root of 25, which is 5. So you could get that 5 again. Okay? So these 4 properties should be remembered. That's the first one. Maybe I use green instead of red. So, So that's the first one. This is another one. This is another property. And this is the last property. Hope we can see that. Okay, so don't forget those 4 properties that I put in green. So these are the properties that will guide us. Anything outside this should not be assumed, should not be written. Okay, anything that doesn't obey these principles is not correct. So I like to move on because of time. Okay, thank you, Dennis, for that attendance. Okay, so like sorts and unlike sorts is the other thing that I want to talk about. Like and like sorts. So we say 2 sorts are like sorts. So let's say you have root A, maybe 2 root A and 3 root A. They are like sorts. Okay, because they have the same radical. If they have the same radical, they are like sorts. If they are different radicals, they are unlike sorts. So if this is 3 root A and this is 3 root B, they are not like sorts because they have different radicals. Does that make sense? So let's write that. 2 sorts are like sorts if they have same radicals. If they have different radicals, maybe I write example first. So for example, 2 root 3 and negative 7 root 3. Okay. Two sorts with different radicals are unlike sorts. Similar to what you know about like terms and unlike terms. They have to have the same variable, okay? So just like in this form, it is in form of a square root. So if you have 2 root 3 and you have 3 root 2, they are unlike sorts. As you can see, their radicals are different. Root 2 here, root 3 here. But in the first one, you have root 3, you have root 3. Does this make sense, everyone?
Yes.
Yes.
Now, why is this right like sorts and unlike sorts really important while we've been talking about them? Why can't we just mind our business? Yes, we can. Because only like sorts can be added. Okay? Okay. All sorts can be multiplied or divided, but only like sorts can be added or subtracted. Okay? So all types of sorts can be multiplied or divided. It's only like sorts can be added or subtracted. That is the reason we are interested in like and unlike surds. So before we go into that, we would like to see how single surds can be simplified. We call them monomial surds. Monomial, remember 2x is a monomial algebraic expression, right? And 2x plus 3y is what? What do we call this? 2x plus 3y.
Binomial.
Binomial. So is 2x plus 3x binomial?
No,
No. Why
No.
is that, Justin?
it only has one unknown.
Yeah, one variable. So this is just 5x, which is still monomial. Yanko, got it?
Yes.
Good. So, but when they have two different variables separated with plus or minus, then they are binomials. 2x times 3y, is it monomial or binomial?
Binomial.
Say that louder.
Binomial.
Binomial. Are you sure? It's
It
monomial.
is no.
Thank you. Is that answering?
Yes, because it's like times
It's
between.
times. So because this is actually 6xy, it's still a monomial. Does that make sense? So please
Okay.
take notes, please. So same way in surds, until they have different, radicals, then they are not considered monomial surds. Okay, until they are not considered binomial, I mean. So when they have the same radicals, even if there are 2 or 3 of them, so 2 root 3 plus 7 root 3 is not binomial surd. Okay, they're still monomial because these two can be combined. This is actually going to be 9 root 3. We will look at why that is the case very soon, and that's probably going to be the last thing we will do. So simplifying it, so we can add and subtract monomial surds. Okay, let's go on. Maybe we can't do the multiplication today, that's fine. So monomial surds. So this is everything we've talked about. So to simplify monomial surd, you need to make sure your radical cannot be simplified further. In the sense that, okay, to simplify monomial surd, I write that. I'm writing this for your own review, okay? So not because the note is necessary, but you can always go back and review it. So you need to ensure that B does not have a factor that is a square number, okay? Ensure that B does not have square number as factor. Square number greater than 1 factor. Okay, so let's see what this means. For example, square root of 8. Shelling, does 8 have square number as factor? You know what the square number is? Talk to me, please, and fast. Fast response will really not waste my time. Yes or no, I don't know what it is. That's better than being quiet. So when I ask you a question, I need that response in 5 seconds. And the response can be positive, can be negative. That's allowed, but not silence, please. Does 8 have factor that is a square number? That's my question. Yes, no, I don't know. I need the response fast.
No.
Say that again.
No.
No. Okay. Let's ask another person. I'm just collecting. What about Mr. Iron Man?
No.
No. Let's see. Rita, how about you?
No.
Sis, Melody, how about you?
I think yes.
What is that?
4.
4. Thank you. Does 8 have a square number factor? Yes. The square number is 4. That is, can any square number divide 8 without any remainder? The answer is yes, and that is 4. Okay. Now, 4 is the only one. Usually you look for the largest square number that can divide it. The largest square number. And the largest square number is actually 4. Okay. So you're going to write 8 as 4 times 2, because 4 is the largest square number that can divide it. Okay. So you can use, remember, because this can be splitted into 2 by one of the properties. Do you remember? One property says we can combine products. Can you see this? One property says you can combine
Yes,
products.
the second one.
Yeah, second property, thank you. So it says we can combine product, which means if you have it in this form, you can actually write it in this form also. Is everybody looking at the board and seeing what I'm showing you?
Yes.
Okay. So that's why we can split it into 2. So now square root of 4 is 2. This will be left in the exact form. So your answer will be 2 root 2. Does this make sense? Let's say square root of 128. What is the largest square number that can divide 128?
64.
64. So this is actually root 64 times root 2. This step is not necessary to be shown. From this step, you can jump straight to this point. And that will be 8 root 2. Can somebody tell me why what I'm about to write is not acceptable? Just a sec. Why is this not acceptable? Let's start with OU.
Maybe because the number inside the radical is still divisible.
Divisible by what?
4.
Divisible by a square number, all right, which is 4 in this case. So that is why it is not, because 8 is not in the simplest form. So this will not be accepted. This is what you should have. Now, when you get to this point, all hope is not lost. You don't erase everything. This is what you can do. All you have to do is say 4 roots. 8 will now be broken down into 4 times 2. Okay, then I can have 4 times, this will give me 2 root 2, because this will become 2. Okay, and that gives me 8 root 2, which is the original answer. Am I making sense, guys?
Yes.
Okay, good. So that's how to simplify. So when you simplify monomial surds, you can actually use it to add and subtract surds. And that's what I'm going to show you next before we close the meeting, because we can now do more practice on our own. And I don't want to come back to this next time. It's actually easy. Is this easy for everybody, or is it difficult for anyone? Is it easy? Can I get some yes or no, please?
It's fine.
Yes.
Okay.
Yes.
Okay. Just making
Yes.
sure. Just making sure we are not taking difficult stuff. All right. I want to show you how it is used for addition, but maybe we shouldn't rush things. Let's simplify this in the next 3 minutes. Try this. So the first one, I have root 12. Do it one by one. I have root 27. I have root 80. I have root 96. I have root 108. You can use the same idea for that. This is the example that we just did. These are using the properties, okay? You can use the properties to do from number 6. When you multiply, make sure you have your answer in the simplest form of Surds. Please ask question if you have any. I'll stop this task at number 10. That's all for today. It's 1 o'clock. So I'll send you the picture to this. Please send me your workings online. Okay? Send me your workings online.
But Mr. Dan, I want to ask if you're gonna put a post, or is it we could send it through WeChat?
I'll put a post. These are easy stuff.
Okay.
I like it to be graded. Okay? I'll put a post. If anybody needs help, please speak up. All right? You can talk to me or talk to anyone in your class. So I'll put a post for this. Okay? And in that same post, if you can solve this, the one on the screen, you can include the solution too. Just try. Okay? Just try. No calculator required. No calculator. No calculator. Okay? If you have to press calculator to do it, then you are missing what I'm trying to get from you. So no need to. It's beyond what you do. These are maybe 4 stages of Olympiad questions. They are not for your level. Maybe someone in IB Form 6 is expected to think outside the box. So I will understand if you cannot do it now. Okay? All right, I'll stop the meeting now. I'll send you the picture right away. Okay, for today's board. Before Giselle start harassing me with messages. Just kidding. Thanks for always reminding me to send the pictures, Giselle. All right, I'll see you guys.
Mr. Daniel, I
Yes,
have a
sir.
question.
Yes, please.
Do we need to put it on the Word document, or do we just send the whole picture?
What documents as usual? What
Okay.
documents so I can grade? Okay, I've been grading some. I think Kelly, I've replied you. So when I grade it, I'll attach what I've graded back and send it to you. If I have comments,
So we still have to like take the picture separately, like one by
yes.
one.
So I can write comment if I need to write comment, because that's the easiest way to write comment. Okay. Henceforth, when I give you work and I need the solution to be shown, you do that Word document thing. Henceforth. Okay. If it is just class activity that I want you to send me the answer immediately, I'll ask you to send it on WeChat. If I give you to try later on your own, send it in form of Word document like we did. Any other questions, please? Like I said, the other roots one is not part of your exercise. If anybody try it, you can attach that at the back of your work in the Word document so I can see, okay? But it's not compulsory. I'm not discussing the solution of the last activity because some people are here to respond. I will please appeal to you to respond quickly so I can discuss the solution with the whole class, okay? So if you're in that category, please submit your work on time. Thank you. I'll see you on Friday.
Bye-bye.
Bye.
Bye. Go. Hello, Justin.